In the late 19th century, many people were interested in this higher dimensional world. Ordinary Euclidean geometry, but instead of having an x and a y and a z-axis, you might also have a w-axis. Not time as a fourth dimension, just adding another space dimension. And that kind of exploration, coupled with this idea that you could have geometries that were not Euclidean, where parallel lines might meet, for example, began to disturb the kind of epistemic certainty of Victorian England, that people began to see what had been the exemplar of perfect knowledge, of absolute deductive knowledge that actually was practical in the world. You could build buildings with Euclidean geometry, you could make maps. But in this world of non-Euclidean geometry, suddenly people began to think, well, maybe even geometry is only a choice or a convention. That was certainly Henri Poincaré's view, who began to popularize what he'd written when he wasn't doing fundamentally new mathematics using higher dimensional or non-Euclidean spaces. He began to popularize this with his extraordinarily successful and rather deep philosophical book called Science and Hypothesis. In it, Poincaré invited the reader to learn how to picture four dimensions. He says this: the images of external objects are painted on the retina, which is a plane of two dimensions. These are perspectives, but as eye and object are movable, we see in succession different perspectives of the same body taken from different points of view. Well, in the same way that we draw the perspective of a three-dimensional figure on a canvas of two dimensions, so we can draw that of a four-dimensional figure from different perspectives of three-dimensional view. This is only a game for the geometer. Imagine that the different perspectives of one and the same object succeed one another. And then he began to teach people verbally how to begin to imagine the projections of four dimensions into three. A mathematician, a military mathematician and artillerist, Esprit Jouffroy, wrote a book which became quite popular. And in it, he drew these extraordinary figures of what it would be like to imagine successive views of a four-dimensional object. Those images in this Jouffroy book then were taken up by mathematician Maurice Princet, who was a friend of Pablo Picasso. And while he was lecturing on geometry, Princet put it this way: you represent by means of a trapezoid a table, just as you see it, distorted by perspective, but what would happen if you decided to express the table as a type, la table type? You would have to straighten it up on the picture plane and make the trapezoid return to its true rectangular form. If that table is covered with objects, the same straightening up process would turn a glass, for example, into a perfect circle. This was around 1909, and the popularization of these images by Jouffroy spread far and wide, including to the emerging school of Cubists. Picasso, as he was preparing sketches that would eventually lead to the Demoiselles d'Avignon, that absolutely pivotal painting in the history of art, began to sketch, for example, in his notebook, Carnet No. 5, images of a figure seen from different perspectives simultaneously, building on just the kind of images that Princet would have shown him from Jouffroy's text. So this sequence that takes us from 19th century non-Euclidean and higher dimensional geometry through the explorations of Poincaré, to Jouffroy, to Princet, to Picasso, is part of the route to Cubism. It's not by any means the whole of the story. It's not causally determinative. It's not as if you simply change the history of art by having a development in the mathematical sciences. But it's a resource that can be picked up and instantiated in the explorations of Picasso. That's one of the ways that science and mathematics get taken up in the arts. And in that period, before relativity has any effect on the arts, you see the scientists' work, mathematicians' work, being drawn up into the arts, so that when in 1919 Einstein's general theory of relativity explodes on the scene, you have a generation of artists who are using these new developments to advance their own cause. A very different pattern of relationship between the arts and the sciences and geometry can be seen in the work of Claude Bragdon, a remarkable, rather mystical theosophist, architect, set designer, author, who took the ideas of 4 dimensions projected into 3 and used them as a way of exploring the different facets of a design he produced for the First Universalist Church in Rochester in 1908. He also used his exploration of geometry to take apart designs for the decorative arts and break them into novel forms of geometrical decompositions. In 1923, he produced a primer of higher dimensional space that became very popular. In 1941, he had an exhibit called Mathematical Abstractions. So he was constantly going back and forth using this late 19th century development of higher dimensional and non-Euclidean geometry as a way of advancing what he wanted to do in the wider world of the arts, pure and applied. Science entered in other ways, too, to trying to get beyond the visible surface of things. You had the invention of X-rays in the 1890s and the fluoroscopic X-ray system in 1907, as people began to be able to image actually the interior of moving bodies as they moved in front of the screen. Sculptors, among them the futurist Umberto Boccioni, whose years are 1882 to 1916, wanted to use static forms of sculpture to indicate motion in a more vivid and abstract way than could be ordinarily contained in a realistic depiction. In 1913, his unique forms of continuity in space produced a huge reaction and became a kind of symbol and stand-in for the whole of the futurist movement. We futurists, Boccioni said, give the method for creating a conception more abstract and symbolic of reality, but we do not define the fixed and absolute measure that creates dynamism. He wanted an openness to motion incorporated in an abstraction woven into a depiction that was in certain ways mimetic. Poincaré had other effects in the world. For instance, he was very closely followed by Marcel Duchamp, one of the great figures of modern art. Poincaré talked about what was called a Dedekind cut, a way of understanding the relationship between a two-dimensional space and a one-dimensional space by saying that a two-dimensional space is picked out by the ability to divide it into parts by a stripe of one less dimension. So a line carves a two-dimensional space into 2 pieces. A plane cuts a 3-dimensional space into 2 pieces. A point cuts a line into 2 pieces. This kind of thinking, spoken of in higher and higher dimensions as Poincaré generalized the idea, then gets taken up by Duchamp himself. The bride stripped bare by her bachelors, even the large glass. Used very explicitly, as we know from Duchamp's writings, this idea of a line separating these 2 parts of the plane to include 2 different metaphysical ways of understanding the subject matter at hand. But these ideas, all of them, whether it's Duchamp or the architects like Bragdon or the many figures in the late 19th and early 20th century who wanted to explore higher dimensional non-Euclidean geometry, were all engaged with science and mathematics without relativity.